Section 4.6, Special Factoring. To begin this section, let's start off with an example. Let's start off by factoring this trinomial, x squared plus 8x plus 16. Well, we learned this from our past section, right? I think that's section 4.4, where we worked with factoring trinomials. And for this case, because our leading coefficient is 1, we can go about it by doing a little x to keep track of our numbers. What numbers multiply give me 16, but add to give me 8, your middle term. So in this case, 4 and 4 works because 4 times 4 gives me 16 and 4 plus 4 is 8. So this factors to be x plus 4 and x plus 4. So is there a way to write this shorter? If I had something like x times x, don't we just write x squared? So we can also take this and write it as x plus 4, and instead of writing it twice, I can write a square. And that's our answer. This is a special type of trinomial and produces a special type of product. So we have a very special answer, right? This is called a perfect square trinomial. Now, how do we recognize a perfect square trinomial? It can save you some time with factoring. This problem wasn't so bad. But one of these, you can follow these steps to easily recognize it. First, the first two expressions, a squared and b squared, must be squares. So you should be able to split up the number and square it. B, there mustn't be a minus between the first and the last, so those square numbers, so it must be positive. And C, multiplying a and b and doubling it is your middle term. That's your middle number. And here you have your formulas. So we have a squared plus 2ab plus b squared is the same as a plus b squared. And a squared minus 2ab plus b squared equals a minus b squared. So we take a look at the same problem we just did. If I label them a and b, I can write a as x squared, and I can write my b as 4 squared, because 4 squared will give me 16. And I notice that my middle term is the same two numbers multiplied times 2. So we get 4 times 2 times x, we get 8x, which is my middle term. Okay, so let's take a look at this next problem. Now, as you've seen, you can factor just as we usually do, but what makes it special is that it's a perfect square trinomial. So you can notice that your first number squared and your last number can be squared. And it just so happens that my middle term is those two numbers multiplied times 2. So we know we have a perfect square trinomial. We have m plus 5 squared. Now again, if that's weird, you can just factor. What numbers multiply to give you 25, that to give you 10, 5 and 5. And then you proceed to factor to have m plus 5 and m plus 5, which would be m plus 5 squared, right? So that still holds, and you can do that if you like. Next example. So whenever you're factoring, always look for a greatest common factor you can divide out. In this case, they can both be divided by a 5. So we have 5, and if we divide everything by a 5, we're left with x squared minus 2xy plus y squared. So if we use our definition above, I see that I have my first term squared, my second term squared, and my middle term is 2 times my first and my last. before they're squared. This time I have a minus. So this factors to be x minus y squared. And don't forget to bring down that 5 you factored down. You factored out in the beginning. Next we have differences of squares. This is your best friend. It's super helpful. Differences of squares says if I have an a squared minus a b squared, it factors to be a plus b times a minus b. So how do you know you're working with differences of squares? A big tell is there are only two terms with a minus in the middle. If you see that, beginning to question if this is a differences of square situation. And second, each term can be written as a square. Now, when we think of this, I like to kind of make you think square roots. Now, we haven't really worked with square roots, but I know you may have seen them in the past. So, for example, the square root is undoing a square. So the square root of 4 is 2. And it's 2 because 2 squared is 4. So in a sense, you want to think of a number that when I multiply it by itself twice gives me some number you're working with. So let's take a look at the example. X squared minus 49. I know we have differences of squares, or I suspect differences of squares because of a minus, and because we have two terms. Okay, now I want to think of, can I take my first number and square it and my last number and square it to get it back? Well, x times x works, and 7 times 7 works. So according to my rule, I take those same numbers and write them with a plus and a minus, so that I have x plus 7 and x minus 7. Now take a look at the next example. It's not as pretty. We have 3m squared n to the fourth power minus 27n squared. Okay, here we see I can't think of a way to square and get 3 as a result. So that's a problem. Is there anything we can do before we start? Well, we can factor out GCF. They can both be divided by an n squared and a 3. If we do, we're left with m squared n squared minus 9. Okay, I know this one's kind of weird, especially with those variables. A trick is to divide your exponents by a 2. So 2 divided by 2 is 1, and 2 divided by 2 is 1. So we have m and n to the first power squared. And for my number, I don't know why I wrote a 3. It's supposed to be a 2. 3 squared gives me 9. So this factors to be mn plus 3 and mn minus 3. Don't forget what you factored in the beginning. There we go. Next problem. Now here, this one's different. We don't have two terms. So what type of factoring can I do when I have four terms? Well, I can go ahead and try to factor by grouping. Let's go ahead and factor my first two and my last two. If I do that, my first two can divide a y to the fourth power, so I'm left with y squared minus 9. And my last two I can divide out 2, so I'm left with y squared minus 9. Okay, we see we have the same thing in the parentheses. So this factors to be y squared minus 9 and y to the fourth power plus 2. Oops, well before we box it, I have to see if we fully factored. And no, we haven't. Here we have differences of squares in this first outside of parentheses because I can take my y and write it as something squared and my 9 and write it as something squared. I can write it as y squared and as 3 squared. So that can factor to be y plus 3, y minus 3, and y to the 4th plus 2. Now we can box it. Now this one kind of looks like differences of squares, but it's an imposter. It really isn't because of that plus. It needs to be a minus. We only have differences of squares with a minus. Sum or difference of cubes. So we can factor two terms that are being raised to a third power, and they factor to be this. Now here we have a trinomial, and I know you want to factor trinomials, but when it comes from a sum or difference of cubes, it is prime. You can't factor it. So let's take a look at these three examples. So for our first one, we're asked to factor x cubed plus 8. Well, I see that I can write this as something raised to the third power and something raised to the third power. Notice it's not square anymore. It's not an exponent of 2. X raised to the third power gives me x cubed. 2 raised to the third power gives me 8, right? 2 times 2 times 2 gives me 8. Okay, so according to my rule, we're looking at this one because it has a minus, and our problem has a minus. I take my number a and b. So that's my a and that's my b. I have a, which is x, minus my b, which is 2. And then I'm going to take my first number squared. So x squared plus 2 times a, 2 times x, plus your last number squared, or b squared, which is 2 squared is 4. And that is our answer. Now again, this trinomial is prime, so you can't factor it any further. It's factored as most as it can be. Let's take a look at our next problem. So we have 2m to the 5th power plus 2m squared. I want to go ahead and begin by factoring out an m squared, and a 2. Factor out the greatest common factor, so that you're left with m to the 3rd power plus 1. And while we might feel that this is fully factored, we should recognize that we have a cubic situation. One raised to the 3rd power is 1, and m raised to the 3rd power is 1. Because I have a plus, we're looking at the one with a plus. So this means this would be your a and this would be your b. This would factor to be m plus 1 times m squared minus 1 times m, 1m, plus 1 squared. So it would just be 1. Then you bring down that 2m you found, 2m squared. That's our answer. Now, let's take a moment to consider our problems. Notice the signs. So, a way to remember these weird signs. I remember one of these teachers said, remember the word SPOP. For same, positive, opposite, positive. So we have, if you look at your sign, we have the same sign. That first one's always positive. That middle one is opposite, and then positive. And it's been 10 years since, and I still remember SPOP when working for cubics. So I hope that helps you remember. Mainly because if you notice we have a plus, but our middle number is a minus. We have a minus, but our middle number is a plus. So it's kind of weird. Just want to take a moment to point that out. Take a moment to observe them, maybe come up with your own way of memorizing them. Maybe write it as a post-it. Okay, let's do one more. Factor b to the sixth power plus 125y to the third power. Okay, so b, I can think of it dividing by 3 because we have a cubic. We have that 3 there. So if we divide by a 3, we're left with b squared. Here we're left with 125, while 5 times 5 times 5 is 125. So that would be 5. So this factors to be b squared plus 5y times my first term squared plus my two numbers, and then your last term squared. Now this one isn't as easy because we have more terms. So first we have b squared squared plus b squared times 5y times our last number squared, 5y squared. Okay, let's clean this up. So this is b squared plus 5y times b to the fourth power plus 5yb squared. And then 5y squared, the square applies to each one. So it'd be 25y squared. And there we have it. Now, here's a summary of all the special factoring techniques we learned in this section. This was section 4.6. Thank you.